Welcome back, everybody. Today we're going to talk about some basic graph functions, parent functions, intervals of increasing, decreasing, and so on. So starting with continuity. Before we talk about graphs of specific functions, we need to review what continuity means. Continuity means that when you're drawing it by hand, your pen or pencil never leaves the paper. There are no jumps and no holes. So if you can trace it from left to right without having to pick up your pencil, then it is continuous. If you're tracing it and you have to lift up, like in this open hole here, I had to hop over it, then it is not continuous. Our identity function. Our first parent function that we're going to talk about is the identity function. F of x is equal to x, or y is equal to x. In this case, this is short for y equals mx plus b, where our slope is 1 and our b is 0. Because it's a linear function, a straight line, the domain is negative infinity to infinity. The range is negative infinity to infinity. We are increasing as we go from left to right because we're going up. And this is continuous because I don't have to pick up my pencil to hop over any holes or start a new part of the graph. This book calls this the squaring function. We're used to calling it the quadratic function. F of x is equal to x squared, or y equals to x squared, which is a parabola. So remember that our graph has arrows here on either end. Our domain is negative infinity to infinity because on the left side we have an arrow going to the left, and on the right side we have an arrow heading off to the right. The range, remember, goes from our lowest point to our highest point. Our lowest point is here at 0 because it's a solid circle. It's a bracket. And then at the top we have arrows going up forever, so that's infinity. And infinity always gets parentheses. In terms of increasing and decreasing, from left to right, we are decreasing from the left side to 0. So that's negative infinity to 0. At 0, we turn things around and start increasing because our pen is going up. And so increasing from 0 to infinity. Remember, increasing, decreasing, constant always uses x values and always uses parentheses. This graph is continuous because when I trace it from left to right, I do not have to lift my pencil up to trace the graph. The shape of this is a parabola with the vertex at 0, 0. Our cubic function, f of x is equal to x cubed, or y equals x cubed. It looks like this graph over here on the right. There are arrows at either end. So on the left side, I have an arrow. That's negative infinity for domain. On the right side, I have an arrow. That's positive infinity for domain. Our range, lowest, is an arrow. Again, negative infinity. Highest is an arrow. So that is positive infinity. This graph is increasing the entire time. From left to right, I'm going up, 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 up. And so increasing would be negative infinity to infinity. They call it the entire domain. The graph is continuous because I don't have to pick my pencil up to trace it from left to right. And the 0, 0 is an inflection point. That's kind of more just knowledge for you rather than anything that you have to memorize. The square root function. We have f of x is equal to the square root of x, or y is equal to the square root of x. There is an arrow right there. Remember, for domain on this, we have to say x is greater than or equal to 0. Because anything less than that, we would end up with negative values under our radical, which are imaginary, and we cannot graph that on the real number plane. That means that our domain from left to right, on the left side, we have x is 0. On the right side, we have an arrow, so 0 to infinity. This 0 has a bracket because, as you can see, this is filled in. Range, same thing. The lowest point is here at y is 0. The highest point is over here at the arrow, so 0 to positive infinity. Tracing the graph from left to right, I am increasing even though it gets less and less and less over time, but it is still increasing for the entire domain, which would be 0 to infinity with parentheses. It is continuous because, again, from the left side to the right side as I'm tracing it, I don't have to lift up my pencil. The cube root function, f of x is equal to the third root of x. We can also make that y equals, and we can also write this as x to the 1/3 power. There are arrows here as well. So on the left side, we have infinity, negative. On the right side, we have positive infinity for our domain. Range, our lowest is this negative infinity. Our highest is an arrow to positive infinity, so negative infinity to infinity. As I'm tracing this from left to right, we are increasing the entire time. The amount that we're increasing changes, but it is still increasing the entire time. We are also continuous because as I'm tracing this, I never have to pick up my pencil to be able to trace the graph. The absolute value function. The absolute value function, f of x is equal to the absolute value of x, or y is equal to the absolute value of x. Our graph looks like this over here on the bottom right of the screen. The domain, on the left side we have an arrow, on the right side we have an arrow, negative infinity to infinity. Because absolute value is always positive, we have nothing below y is equal to 0. So this point right here at 0 is our lowest point, which gives us bracket 0 because that's filled in there. And then our highest points are arrows, which are going to positive infinity. Talking about increasing and decreasing here, as I trace the graph from left to right, I am decreasing from the negative infinity to the 0. And then once I hit the 0, I start going up again, which is increasing. So increasing from 0 to infinity. This graph is continuous because as I trace this graph from left to right, I never have to pick up my pencil to be able to trace the graph. And that is the end of the parent functions that we'll be talking more about in section 2.7. Piecewise functions. Piecewise functions have different rules for different parts of your domain. For example, in A, if our x values are 2 or less, then we use the rule negative 2x plus 5 to generate a graph. If our x values are more than 2, then we use the rule x plus 1 to generate that part of the graph. Basically, what we want to do is take the value that's splitting our rules up and make that the middle of our XY table. And I'm going to put a little squiggly underneath it to show that when we get higher than 2, it changes to this new part. So let's pick -2 and 0 along with our 2. -2 times -2 plus 5 is 9. -2 times 0 plus 5 is 5. And -2 times 2 plus 5 is 1. And so the first part of our graph, the first part of our rule here, is going to have these 3 ordered pairs. Now if I go to the green, let's say I want to do 3 and 5, then I have a new rule, x plus 1. So 3 plus 1 is 4, and 5 plus 1 is 6. To put this on a graph, we put all of it on the same graph. So I'm going to use the blue again. We have -2, 9, 0, 5, and 2, 1. That gets filled in for this part of our graph because it's equal to. For the green part, this would have been an open circle. And then we go to an open circle at 2. I forgot to put 2 in here. I apologize. So 2 plus 1 is 3. So here is 2, 3. There's my open circle. And then 3, 4. And 5, 6. And so there is my graph. The blue is our top rule. It's filled in because of the equal to. The green is the bottom rule. And at 2, it is an open circle there at 3 because it is not equal to here. Let's take a look at the second rule. Second example. We have less than or equal to 0. And so I'll do that in purple. So let's do -4, -2, and 0. And the rule for that is 2x times 3. So 2 times -4 plus 3 is -5. 2 times -2 plus 3 is -1. And 2 times 0 plus 3 is 3. I'm going to use this bottom one when x is greater than 0. So we'll do 0, but remember this is going to be an open circle because it is not equal to. So I'll do 0, 1, and 2, just because of that x squared there. So we would have -0 squared plus 3, which is 3. -1 squared plus 3. 1 squared is 1. That's -1 because of the negative on the outside. Plus 3 is 2. And then -2 squared plus 3. 2 squared is 4. Make it negative. And then -4 plus 3 is -1. So if I make my grid, oops. I go back to the purple to graph. We have -4, -5, -2, -1, and 0, 3. 0, 3 is going to be filled in for the purple because of the equal to. And there's that line. And then I'm going to go back to the maroon here. We have 0, 3. That would be an open circle there for the maroon. 1, 2. And then 2, -1. You can see this is starting to look like part of a parabola here. So there's the other part of that graph. This is where we're going to stop for today on section 2.6. Thank you very much for joining me. Have a great evening.